This is RD Sharma solution, class 12th, chapter 8, solution of simultaneous linear equations, and the exercise is 8.1. Solve the following system of equations by matrix method. Now this can be changed to the question we have already done. So I'll just show you how it is done. Wherever you have this 1 by x, just assume it to be any letter like A. So whenever the answer will come, just take the reciprocal. That is, once you have assumed 1 by x as A, so whatever is the answer, A, you can make it as 1 by x, or x will be 1 by A. 1 by y is B, 1 by z is C. You can take any letter of your choice, doesn't matter, right? Okay, so what will be the equation here? 2a minus 3b plus 3c equals 10. Second equation will be a plus b plus c equals 10. Third one will be 3a minus b plus 2c equals 30. Now this equation is quite known to you now. So you can just use 3 equation and then you can solve it. A, x, b, all you know how to do this. Okay. So a into x is b. So x will be a inverse b. X will be a, b, c. The only thing is x will be a, b, c. And a inverse I hope you'll be able to find out. So let me write the matrix for which you have to find the inverse. So this is the coefficient of A, 2, 1, 3. Coefficient of B, negative 3, 1, negative 1. Coefficient of C, 3, 1, 2. So this one is A, and this matrix A inverse need to be found out. And of course the B is 10, 10, 30. So A inverse I hope you'll be able to do. You can use the cofactor way. And then you can just take the transpose and divide it by the determinant. So whenever the answer will come, just take the reciprocal and that will be your answer. For example, the answer which came here, the reciprocal has to be taken. So this kind of questions are plenty of these. I will encourage you to do all of it. And if you have any problem, then only you can just refer to these answers which I have provided. Okay, so wherever you don't have any variable, you can put a 0. For example, this 0x, so you can put a 0 here. Same thing here, same way you have to follow. So you know, most or more question you do, you will be more proficient. Now here you don't have y, so it will be 0y. The first one you don't have z, so you can write 0z. When the matrix will be formed, it will be like this. Here also you have to make a into x and ax, b, all these, and then wherever you don't have the variable, you just put a 0. This also you'll be able to do, I hope. So these are, the same question. They are just the sub part of that questions. You don't have y here. Okay. This also we have seen just now. 1 by x, assume it to be any letter. A, B, C you can take 1 by x as A, 1 by y as B, and 1 by z as C. So this 2a plus 3b plus 10c, 4a plus 6b plus 5c, 6a plus 9b minus 20c. This will be your 3 equations, and then you can form the matrix and then compute the final values by reciprocating it. Same thing here. Now show that the following system of linear equations is consistent and also find their solutions. So before we go ahead with this question, Let me give you the actual theory behind it. For example, these are just lines. 6x plus 4y equals 2. You can equate it with y equals mx plus c. You can also equate it with ax plus by equals plus c equals 0, or ax plus by equals negative c. So there can be two lines which are same. If I multiply this 2x plus 3y equals 4 with 2, what do you get? 4x plus 6y equals 8. But the line has not changed. So when you have two lines and they are same line, they will be on one another. So you will get infinitely many solutions because every point can be counted. It is just one line because they both are of same line. So you have infinitely many solutions because these two lines, which are single line, are intersecting always. Since it is consistent, because it is intersecting also, two lines same intersecting. There can be a possibility when two lines are parallel, they are never going to intersect. Parallel lines won't intersect. Then we have the third case, which is the actual solution, you can say, when you have intersecting lines. So you have to show here that first of all it is consistent, and then also to find its solution. So first thing is find out the determinant. The determinant of basically A, you have to take the determinant, coefficient of x and coefficient of y like that. So A matrix, this will be coefficient of x. So let me write the 6 and 9, and then coefficient of y 4 and 6. Now find out the determinant of this. What is the determinant? 6 6 is 36 minus 9 4 is 36. Now this is 0. When the determinant is 0, that means this matrix is a singular matrix. That means this system of given equation, it can be inconsistent or it can be consistent with infinitely many solutions. There are two conditions, please remember. It can be, when the determinant is 0, there can be two conditions. Either the equations are inconsistent or they are consistent, but they are not having one solution, they are having infinitely many solutions because they both line are same. They are one over one another. So there is no two lines, there is only a single line. So what we'll do here is, the second case, adjoint A into B we'll find out. We'll find out the adjoint of the matrix. Then we'll multiply it with the B matrix, and then we'll see whether it comes to 0 or not. If this adjoint A into B is not coming to 0, then we say that it is the system of equations are consistent with infinitely many solutions. So there may be case where adjoint A is 0. So we'll take all that cases, but this question is saying that you have to show that it is consistent. When it is consistent and when they both are the same line, that means you will get infinitely many solutions. So I am just taking the adjoint now. I have exchanged the diagonal values and now change the sign of other values. This is adjoint A, and you have to divide it. This adjoint A has to be multiplied by the B matrix. What is B matrix here? 2 and 3. So multiply it with 2, 3 and see what comes. 6 minus 4, 6 minus 9, 6. So multiply it with 2, 3. 6 into 2, 12. Minus 4 is a 12. 9 to the 18, minus 18. And 6 is a 18. So you get plus 18. So this matrix adjoint A into B is also 0. When it is 0, that means that this system of equation will have infinitely many solutions. There are two things. Please remember once again. If determinant of A is 0, which is the case, and adjoint A into B is equal to 0, that is also the case, the system is inconsistent and has, the system is consistent and has infinitely many solutions. They both are same line. Again and again I am telling you, because this is the core of all the questions which are coming right after all this question. So first, determinant of A is 0. In this case, adjoint A into B is also 0. The system of equations are consistent and infinitely many solutions. So in order to solve this, we have to assume y equals k. Then first equation is 6x plus 4 into k, because y is k. 6x is 2 minus 4k. X is 2 minus 4k divided by 6. So you have a value of x, value of y, but they both are dependent on k, and you can take any value of k. That is why you are getting infinitely many solutions. But you have to check one more thing for the examiner to see. Put this x and y in this 9x plus 6y equals 3. I am putting it. So 9 into 2 minus 4k divided by 6 plus 6 into k equals 3. So this 3 3s are 9, 3 2s are 6. Now multiply whole equation left and right hand side by 2. So you get 3 into 2 minus 4k plus 6k, that is 12k equals 6, because we have multiplied by 2. So what do you get? 6 minus 4 is 12k plus 12k equals 6. This gets cancelled. 6 is equal to 6. That means that it is satisfying also. So clear? Show that the following system of linear equation is consistent and find their solution. So determinant of A will find out adjoint of A into B. If they both are 0, that means this system of equation are consistent and with infinitely many solutions. So the A is 2 3 6 9. So 18 minus 18 is 0. What do you get? 18 minus 18 equals 0. Determinant of A is 0. That means this is a singular matrix. Now we'll find adjoint of A multiplied by B. If this also comes to 0, then we'll do the same thing what we have done earlier. So adjoint of A, when adjoint of A is 0, that is a different scenario. We'll talk about that. The questions are coming. But right now, determinant of A equals 0 and adjoint of A into B equals 0 is our main key of these questions. So I'm writing the adjoint and then multiplying it with B, 5 and 15, you get 0 0. So when you get 0 0, again, determinant of A is 0, adjoint of A into B is 0, they both are 0. That means infinitely many solutions, but the system are is consistent, because there are two lines which are actually one line and they are intersecting. That means you have infinite points of solution. Okay. So what you have to do here is, you have to assume y equals k, 2x plus 3k equals 5, x will be equal to 5 minus 3k by 2. So x and y, they both are dependent on k. K can be chosen by you, any value you give, whichever is possible, and you will get infinite solutions. Infinite solution because of the k, and k is up to you, right? Now this x equals 5 minus 3k and 2 divided by 2 and y equals k. This needs to be put in 6x plus 9y equals 15, also to show that these two equations, which are actually one equation, I'll just show you how these are one equation. See, 2x plus 3y equals 5. Now multiply both sides by 3. What do you get? 6x plus 9y equals 15, and this is nothing but the second equation. Okay? Infinite solution. Show that the following system of linear equations is consistent and also find their solutions. So this will come as a 3 by 3 matrix. But the procedure will remain same. Ax equals b. What is A here? Let me write it. Coefficient of x 5 3 7. This is A I am writing. Coefficient of y 326 2. Coefficient of z 7 to 10. This is your A. Now what is x here? X will be x, y, z. What is B here? 4, 9 and 5. This is B matrix. A matrix you have, B matrix you have, and X matrix you have. So first you have to find out the determinant of A. So you know how to find out the determinant. Let me tell you, the answer will come as 0. So now when the determinant is 0, there are two possibilities. Either the equations are inconsistent or they are consistent with infinitely many solution. In order to check the infinitely many solution, we have to find out the adjoint of A and we'll multiply it with matrix B and we'll see whether it is 0 or not. If it comes, then we can say consistent and infinitely many solution. So adjoint A into B is the second step what we have to do. I hope you'll be able to do that because adjoint of A we have already done number of times. If you have been following my discussions, we have been doing it quite a lot now. So this is adjoint A. Adjoint A, cofactor matrix transpose is adjoint A, and multiply with B. B I already showed you what is the B matrix, 495, and when you multiply it, it will be 0 again in this case. So when you have determinant of A as 0, adjoint of A multiplied by B is also 0, that means the equations are having infinitely many solutions. So same thing you have to do, but there is 3 by 3 matrix that will come as 2 by 2 matrix and you will solve like that what we have seen. So first Z equals K you have to assume. First equation will be 5x plus 3y plus 7k equals 4. I am taking 7k on the right hand side because it is constant. All constant has to be taken on the right hand side. Say 3x plus 26y and 2z, that is 2k, has to be taken on the right hand side. So you get 9 minus 2k. Then you have 7x plus 2y. Take this 10k on right hand side. But you are not going to take the third equation. Why? Because third equation will use to show that the values which we get satisfy it. So first, here also you have to do the same thing, same procedure. Determinant A, please find out determinant of A. What is determinant of A? Because A, x equals B, x equals A inverse B, determinant of A is 26 into 5 minus 3 into 3. You'll say it will come as 121. That is determinant of A is not equal to 0. Then you have to find out the adjoint A. What is adjoint A? I am changing the sign, exchanging it and changing the other sign of other values. What is A inverse? Adjoint of A and divided by determinant of A. So this is determinant of 121 is the determinant of A. This is your matrix and this is your going to be A inverse. So now in order to find out x and y, A inverse into B you have to do ax equals B, x will be equal to A inverse B. So this is 1 by 121, 26, negative 3, 5. And now you have to multiply it with the 4 minus 7k, 9 minus 2k, because this is in this matrix, these two are the constant values, our B matrix. Now when you solve this, you will get x and y in term of k, because what you have done, you have assumed z to be k. So you get 7 minus 16k by 11 here. Y will come as 3 plus k divided by 11. That means x and y are in terms of k. Z is already k. So this will give you infinitely many solution, because k is infinitely, you can give any value of your choice you can give. And the best way is to show the examiner is to take these three values, put it in 7x plus 2y plus 10z equals 5 and show it that these things, these values satisfy this equation. So now these type of questions are coming. Same thing, the procedure I told you, you have to adopt the same procedure here. Okay. So first is Ax equals B. Then you have to find out determinant of A. It is 0. Then you have to find out adjoint of A into B. If this also comes to be 0, then you will say infinitely many solution. In order to find out the solution, that is infinitely many solution, you have to assume Z to be K. Z is K. Now you make it as 2 by 2 matrix, that is Z will go, that is K will go on the right hand side, and then you will do it the same way and find out the solution of x and y in terms of K. So x minus y equals 3 minus k, 2x plus y equals 2 plus k, minus x minus 2y equals 1 minus 2k. Use this, and same thing you have to do here with 2y2 matrix. So ax equals b, determinant of a you have to find out, adjoint of a you have to find out, a inverse you have to find out, put it in the x equals a inverse b, and then you will get the answer in terms of k. Because z is equals k you already assumed. Put it in minus x minus 2y plus 2z equals 1 to satisfy it. So these questions are same. Just try it again and again. Now these type of question contains everything. They contain cofactor, they contain the transpose, they contain the adjoint, they contain the inverse. So this, you can say, amalgamation of all the matrices activities we have seen up till now. So all these you have to do, which I just explained you, and I will encourage you to first solve by yourself, then only try looking at the answers, because these are just for your reference. Show that each of one of the following systems of linear equation is inconsistent. This question will take in the next discussion. Thank you so much. Take care of yourself.